In this video, I'm going to teach you about combinations and permutations. So combinations, and permutations. Okay, so you can have two different types of cases. One is called combinations, one is called permutations. In general English language, we call them both as combinations. So let's talk about first permutations. So an example of a permutation can be a password field or a locker combination. So what it means is, like, a locker combination can be, let's say, a 3-digit locker combination might look like 978. And here what you'll notice is, or a password might be, let's say, let's just call it password. Very bad password, not one you should use in real life, but let's say that's our password. So this is an 8-letter password. Now, there are two important things to note here. One is, can we repeat the same thing? So can we repeat, let's say, the same digit 99, or can we repeat a letter like SS? So we can. And so this is a property of repetition, repeat. And the other property that matters to us is ordering. So does the order matter? So, like, if you switched the order of these letters, it would be a different password. So the order does matter, right? So when the order matters, we call it a permutation. And when the order does not matter, we call it a combination. So for example, if I told you that you have a bunch of ice cream flavors at an ice cream shop, and you can choose any 3 flavors for your ice cream cup, it does not matter in which order you put the flavors into the cup. You just know that you're going to put 3 flavors into the cup. Now, if I told you that they all have to be different flavors, that would mean that they cannot repeat. And if I told you that they can be the same flavor, like you might say 2 scoops of chocolate and 1 scoop of vanilla, then you would say they can repeat. So when we speak about repetition, if you see word problems to do with combinations and permutations, the key word will be different. So if you say different, things don't repeat. And if you don't say different, things can repeat. And when it comes to order, when the order matters, like in the case of a locker combination or a password, we call it a permutation. And when the order does not matter, like in the case of these ice creams here, then we call it a combination. Okay, I hope that's clear. So let's say that you had a bunch of students. Let's say you had 5 students: Rohan, Mohan, John, Gina, and Lindsay. And you were going to place these 5 students in a race, and then they would get first, second, and third places. Then can they repeat? So the answer would be no, right? Because Rohan, one person would not be able to take 2 spots. So Rohan can't be first and second, for example. And does the order matter? So yes, because if you change the order, then their positions would change, right? So they would not be. If Rohan was first, then he needs to be in the first spot. If he's second, he needs to be in the second spot. So the order matters. So this race would again be an example of a permutation. And let's say I told you some probability problem, like, here's a bag of various colored balls, and this bag is full of, red, blue, green balls. Maybe this is a bag of M&Ms, and you get to pick, let's say, 5 of those M&Ms. So that would be an example of a combination because the order won't matter. You're just going to try to figure out, hey, did I get 3 yellows and 2 blues out of the bag? So if that's clear, then let's move on to, so this is basically understanding that when the order matters, it's called a permutation. And when the order does not matter, it's called a combination. So that's what I want you to remember from this. And now let's move on. So to move on here, so what I want to do now is to talk about permutations first, where repetition is going to be allowed. So let's say that we have, the order matters and repetition's allowed. So we might have, let's say 3, 3, 4. We could have 3, 2, 1. So this is maybe a 3-digit locker combination. And now I ask the question, how many combinations are going to be there given n spots? So 1, 2, all the way to n. And our different possibilities. So our possibilities for each spot, right? So n spots and r possibilities. So how many things can you put in the first spot? R. How many can you put in the second spot? R, R, and R, right? Because you're allowed to repeat and the order matters. So how many possibilities will be there? R times R times R times R, and you're doing this n times. So basically the formula is just going to become R to the n. And this is essentially all you need to do. If you have r possibilities in n steps. Now, I mean, you can reverse n and r and say, okay, there's n possibilities in r spots or whatever, but so you'll just swap. Different people might have different ways of writing it, but essentially it's going to be an exponential, right? So if I told you for this locker combination, how many combinations are possible, and you know that there's 10 digits, 0 through 9, and you have 3 of them, so it's going to be 10 times 10 times 10, which is 10 to the third, or 1,000. So it's that simple. So this is the first case where we had a permutation where repetition is allowed. Okay. Now let's move on to the second case where we're going to have a permutation but repetition is not allowed. So for example, we said in the case of the race where our 5 students were racing, and then we had to give them first, second, and third places. So first, second, and third, let's say Rohan came first, Lindsay came second, Gina came third. So how many ways can these combinations happen? And so now for the first, since we have 5 students, for the first spot, first, second, third, you have 5 students to choose from. Now you've already chosen one of them and he can't come back in the second place as well. So you have 4 left for the second spot. And then for the third spot, you have 3 of them left. So you will basically put a 3 here. And you will multiply them because that's how many possibilities you will get. So you should know that when you have an and, like you want first place 5 people and second place 4 people and third place 3 people, you would multiply. But if you had an or, for example, this many for first place or this many for second place or this many for third place, that's when you would add. So in this case, this is an and, so we will multiply. So this multiplication here gives us 20 times 3. So basically there are 60 ways to put first, second, and third places from 5 students. Now if we had 10 students, this would basically become 10 times 9 times 8 which would be 720, right? So this is how you would do a permutation without repetition, or where you needed to pick different people. Okay? Now, if you don't know what a factorial is, a factorial basically means that if you had 5 factorial, you're going to multiply 5 times 4 times 3 times 2 times 1. And what this essentially tells us is how many ways can we arrange 5 people. So, for example, if I was just taking our 5 students and arranging them, I could put 5 people in the first spot, 4 in the next spot, 3 in the next spot, 2 in the next spot, and 1 in the next spot. Now, if I had no people, I would basically be able to put no people as one possibility. So we will define 0 factorial to also equal to 1. So both 1 factorial and 0 factorial will be 1, because there's one way to put them, because that makes a lot of the math easier. And for any other number, it's going to be that number times n minus 1 times n minus 2 times n minus 3 all the way down to 1. So that's what a factorial means. So now that you understand what this factorial means, let's actually take the factorial of, let's say, 5 factorial and divide it by 3 factorial. Let's see what that does. So this is a neat little trick, right? So what's going to happen here is 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1, right? Because 3 factorial is 3, 2, and 1. Now you can see that 3, 2, and 1 are going to cancel with the 3, 2, and 1 here. So you just get 5 times 4. Now, if you see here, we were trying to get 5, 4, and 3. So what could we do? How can we represent this 5, 4, and 3 in terms of factorials? We could say this is 5 factorial over 2 factorial, right? Because that would give us 5, 4, 3, 2, 1 over 2 and 1. 2 and 1 will cancel, and so we will end up with 5, 4, and 3. And so that would exactly be this. So when you had 5 people, and you had to pick 3 of those people for the first, second, and third spots, you could write that as 5 factorial over 2 factorial. Now, this 2 factorial is actually the difference of what's left, right? So if we chose 3 of them, we are going to take 5 minus 3. So really what we're saying here is that this is really 5 factorial over 5 minus 3 factorial, right? So basically the 2 factorial. So what is this? The 5 is the number of students we have, and the 3 is the number we're trying to pick. So this is basically, let's say R is the number we're trying to pick, and N is the number we are trying to pick from. So we're going to get N factorial over N minus R factorial. So that's our permutation without repetition formula. Okay? So you're going to try to remember this formula. Permutations without repetition are basically just like you're trying to pick 3 spots, so you're just doing 5, 4, and 3 for 5 people, or 10, 9, and 8 for 3 people out of 10. But the formula mathematically looks a little bit more complex, but it's actually really easy. It's n factorial over n minus r factorial, because the n minus r terms are simply going to cancel like I showed you here. And so this n factorial over n minus r factorial will essentially give you r terms, the first r terms of the factorial. So like if I said we have 50 factorial over 47 factorial, what that means is we're going to get 3 terms, which is the difference. So this is basically 50 times 49 times 48. Okay, so So if you see a factorial over another factorial, this is essentially what we're talking about. So now this is basically permutations without repetition. So let's continue and let's move on to our next case, which is going to be combinations without repetition. So let's talk about combinations without repetition. So how's that going to work? So we said an example of a combination was the ice creams. The order doesn't matter, and we are allowed to repeat. So what does this mean? So for example, let's say I have 5 flavors of ice cream, and I want to choose 3 of these flavors for my cup, and I'm allowed to repeat a flavor. So if, let's say, so now with the combination, remember, we're going to try to figure it out, so the order doesn't matter. But let's first take the case where the order does matter. So what's going to happen if the order mattered? We're choosing 3 flavors if the order matters. Let's say chocolate, vanilla, strawberry, chocolate, 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 vanilla, like this, right? And we already learned that if the order matters, it's a permutation. And if that's a permutation, we already learned that this would basically be 5 factorial over 5 minus 3 factorial, which would be 2 factorial. Sorry, this handwriting is a little bad here. Let's fix that. 5 factorial over 2 factorial if we're picking 3 flavors. Remember, this is n, right? But if we did this, we're going to get some extra combinations because we're going to count chocolate 1 and chocolate 2 as different from chocolate 2 and chocolate 1 if we did it the permutation way. So we also need to further divide it by r to eliminate these 2 possibilities as a and make count this only once and not twice. So basically our formula before was n factorial over n minus r factorial, and now since we also want to eliminate the possibilities that are duplicated, there are basically going to be r factorial duplications. So for example, since we are choosing 3 flavors, we're actually going to have 6 repetitions. And I'll leave this as an assignment for you to verify this by actually expanding possibilities and making sure for yourself that there's always r factorial extra possibilities when you do a permutation instead of a combination. That is, the order matters instead of not mattering. So we're going to divide this by r factorial here. And that is basically going to be our formula for a combination. So combinations can be written various ways. One way to write them is in parentheses like this, 5, choose 3. Another way to write it is to say 5, C3 like this, or some people might write it as 5, C3 like this. But they all essentially mean the same thing. You're choosing 3 things from 5 things where the order does not matter. And the formula is basically n factorial over n minus r factorial divided by r factorial, where r is the number afterwards, the 3, and n is the 5. Okay, so similarly for permutation, you would have written it as permutation of 5 and 3, or 5 perm 3. The bracket notation does not actually apply for permutations, but some if you wanted to, you might write it as a function of 5 and 3, something like this. So in the case of permutation, since the order matters, you're going to have more combinations. You're not going to divide by the r factorial. In the case of combinations, you will. Okay, so if we're clear up to there, let's go to the last case, which is basically combinations where repetition is allowed. Combination with repetition. And so remember this one, okay, sorry, I should not have written C1, C2 because we didn't allow repetition, but this would basically be a different flavor, let's say, I don't know, cranberry. So we'll say chocolate is C1, C2 is cranberry or something. So correct. So if you said CVS, let's just, I said we'll leave it to you as homework, but I'll just go over that here. So let's say you said CVS. So you could say chocolate, vanilla, strawberry. You could say vanilla, chocolate, strawberry. You could say strawberry, vanilla, chocolate. So chocolate's moved through all three positions. Vanilla is not moved through all three positions. So you can say, let's see, CVS, CSV, and then C. Okay, so C was in the first spot. These two had both spots reversed. V's in the first spot. CS, V in the first spot. SC, and then S in the first spot, and CV. So here's your 6 combinations, which is basically the 3, 2, 1 factorial or R factorial, as the various ordered combinations of the same. And so these 6 combinations all will get combined when you divide this by R factorial. And so that's how you're going to make the order not matter. So if you have 3 things and you wanted to interchange them in various orders, you already know from what I said earlier about, okay, there's a lot of writing here. Okay, let me not confuse you. But basically what it means is if you have 3 things, you can order them in 6 ways, or 3 factorial ways. If you have 5 things, you can order them in 5 factorial ways, which would be 120, 5 factorial, 5 times 4 times 3 times 2 times 1, 20, 60, 120, right? Yeah, so 5 factorial is 120. And so if you have 5 things, they can be ordered in 120 ways. Just to quickly elaborate, let's just do a couple of factorials: 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial. So 1 factorial, 0 factorial also. Let's keep it 1, 1, 2, 6, 6 times 4, 24, and then 24 times 5, 120, and then 120 times 6, 720. So up to 6 factorial, this is what the table looks like: 1, 1, 2, 6, 24, 120, and 720. Since you might encounter these a whole bunch of times in your problems, it's probably just useful to have seen these, because you'll recognize that if you see a 5 factorial, it's 120. If you see a 6 factorial, it's 720. For larger ones, you can do the computation. Okay, so moving on to combinations with repetition. So if you think about combinations with repetition, you can think of, let's say, that you have an ice cream. Let's say you have a 4B. Let's say you have some combinations of banana, chocolate, lychee, maybe strawberry, and vanilla. Okay? So I just wanted to keep some different letters here. So let's say that you have these. And now you want to take, let's say there are 5 of these flavors, you want to take 3 of them, and you can't, the order won't matter, but you're allowed to repeat. So it could be C, C, and L, for example. And the C, C, and L will still be the same as L, C, C, right? So these two should be the same. And you can think of this as maybe going through a little exercise of, you're going to step through these and pick X number of scoops of each one. So let's say that you're going to say, I'm going to go through, let's think of a little robot, mechanical arm or robot that goes through and picks each of these scoops and picks a certain number. So every time the robot arm moves, I'll call it 1 step forward with an arrow. And every time he scoops, I'll make a check mark. Okay? So how many times is it going to move through is always going to be 4 for the case of 5, right? So it's always going to move through n-1 times if you have n flavors. So you have n flavors, and it's always going to move through n-1 times. And it's always going to pick 3 scoops. So it's always going to pick R scoops, right? So it's going to move n-1 moves and pick R scoops. So you just need to know how many ways can you make n-1 moves and do R scoops, and choose how many of these are possible. So you're basically going to do a combination of R plus n-1. That's how the robot's going to move. It's going to move, let's say it might go, move 1, pick 2 scoops of chocolate, move 1, pick a scoop of lychee, and then move. So that's basically going to be a move, 2 of this, move, 1 of this, move, 1 of this, move. And so you just need to find how many combinations of this robot movement are possible, which is R plus n-1. And you will pick R from this. And so what does that come out to? That's basically, you already know the formula for the combination from earlier. So what is it? The numerator here, factorial. So R plus n-1 factorial divided by the denominator factorial times this minus the denominator, so factorial, so n-1 factorial. And this is basically it. This is how you come up, this formula here is how you would come up with combinations with repetition. So I hope that made sense. If it didn't, go back over the video and think about it again. But basically, if you did not divide by this R factorial here, you would end up with all the permutations, and then the order of your ice cream would also start to matter, right? And you don't want that, so that's why you have that R factorial. But this is it. So we have covered all the 4 cases. We have covered the case of permutations with repetition, permutations without repetition, combinations without repetition, and combinations with repetition. So I don't want to make this problem too long. Maybe I'll do another video with practice problems later, or you can find some practice problems online or in a probability book. But enjoy.